Okie doke. Does everybody see where we're at? 2, 3 graphing lines. Found it okay? Okay, our goal for today is twofold. So there's 2 things you're going to be able to walk away with today. First, you're going to be able to graph linear equations in slope-intercept form, and you're going to be able to graph linear equations in standard form. Your motivation is when someone shows you who they are, believe them. That comes to us from Maya Angelou. So what do I mean by this? Why is this tied into our lesson for today? Well, when an equation shows you what it is, you should start to believe it. That's kind of the tie-in there. And what I mean by this is we're going to go ahead and define these things. It is a big idea in this class. Right now, you're recording the definition for a parent function. And a parent function is the most basic function in a function family. The most basic function in a function family. A function family is a group of functions that share the same characteristics. So, just like you have a family, and a lot of you have parents, and you have similar traits to your family, your parents, well, we have function families also. And function families sort of spring out of these parent functions that we're going to talk about. Our first parent function is the parent function for linear functions, and that's going to be y equals x. And just a side note here, I have a poster in my classroom that breaks down our function families. It's this dance moves poster over here. So anytime we learn a new parent function, you're going to see that it's sort of a dance move that we're going to practice in class. Now, you're probably saying, why do we have to dance, Mrs. Lucas? Well, you know I'm a big fan of the brain science and stuff, right? And I'm a big fan of those things we call modalities. Well, if I get you to move your body, it's just another way that that information gets planted into your brain. So don't be embarrassed. You have to have 0 rhythm because I have 0 rhythm and 0 coordination. But we are going to periodically, I'll stand up, I'm going to yell out a parent function, and you're going to show me with your arms what it's going to look like. And we will do that at the end of class today. So what I wanted to let you know is that we are getting our first dance move today. We are getting our first parent function today. And what I also need to talk to you about that idea is ultimately, you know how courses have like big ideas that your brain needs to do, like this course must do this for you. Well, in Algebra 2, we have a big idea. This course is designed to, at the very least, tattoo certain images on your brain. So that if I give you an equation, like a y equals x, blah, 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 if I give you an equation, you can immediately start to picture what that graph looks like without hesitation. So it's the marriage of those 2 ways of representing mathematical concepts. We're going to join together the idea of an equation and a graph so that you begin to see them very fluidly as one sort of thing, one sort of cohesive piece. That's a big idea in this class. If I give you a graph, you can write an equation. If I give you an equation, you should be able to give me a graph. They should start to talk to each other like that. So we start with these dance moves. We start with these parent functions. And what I need to tell you is that every chapter we have is dedicated to a different function family. So this function family that we're studying in chapter 2 is lines. So what is every single graph in this chapter going to look like? Lines. Very good. So every single graph, we're going to stretch it, we're going to shrink it, we're going to move it up, we're going to move it down, we're going to move it to the right, we're going to move it to the left. But everything you draw has to be linear, or else you know you're messing it up. So what I wanted to tell you is that it's a big day for you. You're getting your first function family, and that is the line. So just a couple of key pieces of information about, not to make the mistake there. Just a couple of key pieces of information about your graph. First of all, y equals x has one critical point. And that critical point In this case, it's both an x and a y-intercept. They're going to classify it as a y-intercept here. And it is the origin. So this graph contains the point 0, 0. The other key feature of this graph, if I'm looking at this equation, I could actually rewrite it. It's going to be y equals 1x plus nothing. So we're beginning to understand where that 0, 0 comes from. It's the fact that our y-intercept, or our b value in the equation, is 0. Also, you might recall from Algebra 1 that the number in front of x is what we call our slope. That's what we're going to take care of today in class. So if you're like, why is there an m there? Don't worry, I'm going to get to that in a little bit. But if you remember from your Algebra 1 or geometry class, that number in front of x is your slope. And in this case, the slope is 1. See that? The slope of this line, I'm looking right here. The slope of this line, y equals x, the slope is 1. So what does that do for our graph? Well, what you're going to see is that from point to point to point, we go up 1 over 1. Up 1 over 1. The rate of change, or the rise to run, is up 1 over 1 between all of our points. So those are some key features of your parent function. And just in general, they go ahead and they define a y-intercept for us down here. In general, your y-intercept of your graph, wow, this is not doing a great job today, guys, I'm sorry. Super pixelated. The y-intercept, just got to write slower so it can keep up with me. In general, a y-intercept of a graph is the y-coordinate of a point where the graph crosses that y-axis. In other words, that is the point 0, b. Sure. So you got a couple of little bedazzlings on your graph there, and you have your definition all filled in. Okay, so let's not get too far off topic. I got to teach you two things today. We're going to review y equals mx plus b. We're going to review ax plus by equals c. I do teach this like it's a little bit of a review because it's prerequisite information for moving forward in the chapter. If this is like Chinese or Japanese to you or something foreign, please holler. The rule is if you don't understand what you're writing, you shouldn't write it down. You should ask a question instead. Okay. So, what is slope-intercept form? Quite frankly, it's just a linear equation of the form y equals mx plus b, where m is the slope and b is your y-intercept. Should we hope to graph a line using slope-intercept form, I break this down into 4 simple steps. Step 1, you should write the equation in y equals mx plus b form by solving for y. In other words, you got to get y all by itself on one side of the equal sign. And then we write the polynomial on the right side of the equal sign in standard form. So it does go mx plus a b value. Step 2. We always start, after we have this equation, we start by plotting that starting point, aka our y-intercept. Our y-intercept is a point always of the form 0, b. That'll be the spot where your graph crosses the y-axis. So you're going to put a point on your y-axis. After that, we move into step 3. We're going to identify our slope, which is your m value. And I always count it off as a rise over a run. This is the definition of slope I'll be using in this lesson. And the last step is I connect the points that I've drawn. So you draw a line to connect your points. Again, you should be drawing lines for the majority of tonight's assignment. Okay, let's do this. The version of Adobe Editor I think that the Copy Center uses is different than mine, and every once in a while that pushes out goofy things. So you see a big 3 and a 2 on your paper. If you want to, we're going to practice graphing right now. Y equals negative 3 halves x plus 1. If you want to just cross that off and rewrite the equation on the next page. So we're going to go ahead and practice graphing the equation y equals negative 3 halves x plus 1. Step 1, solve for y. Hey, look at that. Y is already by itself. So I don't even have to worry about that step. That's kind of nice. I also noticed that the right side of the equation is in standard form, so it does go that mx plus b. Step 2, identify your y-intercept. That's easy to do because that's always that b value plugged in at the end. So since b is equal to 1, I'm allowed to start by plotting the point 0, comma b, which in this case will be 0, comma 1. And I'm just going to draw out a little graph here off to the side. I need a y-axis and I need an x-axis. And then I'm going to plot my point, 0, comma 1. It's not a bad idea to throw down some tick marks. So I'll do 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I just made some tick marks there. You'll have graph paper for your assignment for tonight and the rest of the graphs, I think, in the chapter. This one just didn't copy. Okay, so I'm going to go ahead and plot that point 0, comma 1. Do you see how it's a y-intercept? This is the place where my graph is crossing that y-axis. So by definition, it makes sense. So that was step 2. Step 3, we're going to identify our slope. And I always like to count it off as a rise to run. So I see here my slope is negative 3 over 2. So if I use my definition of rise to run, a rise of negative 3 is actually down 3 units. And since this is a positive 2, I'm going to move to the right 2 units. Notice my slope is negative, which we learned results in a decreasing graph, or a graph that falls, if you'll recall from section 2.2. So my graph should go down. Use your eyeballs. The slope was negative. So I'm going to go down 3, 1, 2, 3, over 1, 2. Now I'll put another dot. Now you actually only need 2 dots to make a line, but I usually carry out a couple of points just to make sure. I don't always have a ruler on me, just to make sure I have an accurate picture. So I'll repeat this slope, counting it off just a couple times. So I'll go down 1, 2, 3, over 2. And then I might even repeat the pattern in reverse. So I'll go up 3 and to the left 2. Up 1, 2, 3, to the left 1, 2. So that'll give me another point to plot. And then, it's hard to do on a tablet here, but I'm going to try to swing through. And that was step 4, where you connect the dots. So again, step 1, I got y by itself. Step 2, I identified my b value and I plotted it. Step 3, I identified my slope and I counted off the rise to run to get to another point. Step 4, I connected the dots. Step 5, you could check it. You want to throw that into your calculator in your y equals screen, you could type it in. And then you should get a line that looks like mine. And if you go to the table of values, you should see these ordered pairs. You don't have to do that, but that's if you're worried about it. Okay, questions about that? Okay, so that's objective 1 down. From example 1, let me see here. Yeah, y equals negative 3 halves x plus 1. So this was an equation that was in the form y to objective 2. Standard form. Standard form's not y equals mx plus b. Standard form is an equation of the form ax plus by equals c, where a and b are both not 0. So So once again, it is a linear equation of the form ax plus by equals c, where a and b are both not 0. And this whole idea of being not 0 makes sense to me, because if I let a equal 0, my x is going to go away. And if I let b be 0, my by term goes away. I end up with horizontal or vertical lines if that's the case. So, now, standard form, obviously different than y equals mx plus b. Why it exists is because it quickly allows us to find not just a y-intercept, but also an x-intercept. So with that, we should take a second to define the term x-intercept. So an x-intercept is the x-coordinate of a point where a graph intersects the x-axis. Once again, our x-intercept is the x-coordinate of a point where a graph intersects the x-axis. So using standard form to graph an equation also has 4 steps. Step 1, we write the equation in standard form. I would like to show you how to do this step because the next example actually already has the equation in standard form. So I was just going to have you jot something else down as another example, just so you have it for reference. In your homework tonight, they ask you to practice writing equations in standard form. So it's a good time to maybe even, let's just take the one from example 1 and show you how you could write that equation in standard form. So I think the equation slope-intercept form, so let's use that for just a second. So let's say I wanted to do step 1 on my equation y equals negative 3 over 2x plus 1 from the previous example. Mx plus b, but I need to turn it into an equation of the form ax, bless you, plus by equals c. So I'm showing you in this little, it's not really an official example, I'm just kind of adding to your notes a little bit here. I'm just showing you how to switch out the form of an equation comes in. Notice, when we do this, when we do standard form, the x and y are on the same side together. They're on the same side of the equal sign. Well, as I look at this first equation right here, I'm like, wait a second. Those aren't on the same side of the equal sign. But I could pretty easily get that x term over to the other side. And I just do that, super easy. I'm just going to add 3 over 2x to both sides. Like that. So now, if I just balance the left side of that equal sign, what do I have? I have 3 over 2x plus 1y, and that right side balances to just reduce down to 1. So do you see how I have an ax plus a by equals c? So that's in standard form. That's all you do. Not too bad. Okay, wait, it gets better. Some textbooks will require, to fully meet the definition, their definition of standard form, they require only integer coefficients. In other words, see this here? It's a bad guy because it's not an integer. It's a rational number. It's a fraction. Fractions are not the same as integers. So how do I get 3 halves to then all of a sudden be a whole number? Oh, we're going to use your friend and mine, the LCD method. So what I'm going to do is I'm going to go ahead and go one step further, and you'll see this, I think, in a little bit in your homework tonight. They want your a, b, and c to be integer coefficients. I would go ahead and distribute that 2, because that's the LCD of all the fractions in the problem. I would distribute that 2 into my parentheses. And so if I had 3 halves of 2, that's 3, plus 2y equals 2. Now that really looks like that ax plus by equals c form that they kind of prefer. So that was just a side note. That's doing step 1 if you have to. Write the equation in standard form if needed. Okay, why this form is useful is because it basically gets us the 2 points we need to draw a line. But the 2 points they want us to draw here are just your x-intercept and your y-intercept. So step 2, you identify your x-intercept by letting y equal 0 and then solving for x. We then use the x-intercept to plot the point where the line crosses the x-axis. Step 3, you then identify the y-intercept by letting x equal 0 and solving for y. You use the y-intercept to plot the point where the line crosses the y-axis. Last step, connect your 2 dots. All right, let's give it a try. So here, pretty close to the one we just did, actually. Do you see how we have an equation in standard form? It fits that ax plus by equals c form. So step 1's kind of done for us. It is in standard form. Step 2, I go ahead and I identify my x-intercept. Ugh. I don't like it. It's messy. Sorry, fixing it up for you. Alright, so I'm going to go ahead and identify my x-intercept. And we do that by letting y equal 0. So I will go ahead and say, okay, 2x plus 3 times 0 equals 12. 3 times 0, that's just 0. So I get 2x equals 12. Divide both sides by 2. I get an x value of 6. So now I know that is going to be the point 6, 0. So I'm going to go over to my graph and graph the point 6, 0. 1, 2, 3, 4, 5, 6, 0. And you see how it lands on the x-axis there? That's because we calculated the x-intercept. Step 3, we're going to go ahead and now calculate the y-intercept. And we calculate the y-intercept by letting x equal 0. So I have 2 times 0 plus 3y equals 12. 2 times 0, that's just 0. So I get 3y equals 12. Divide both sides by 3, I get a y value of 4. So when x was 0, y was 4. So that, I can plot it and see how it lands on the y-axis. That means it fits our definition for being our y-intercept. So,
why can't you just plug 6 in?
when you said it, again, that pronoun sometimes slays me.
Why can't you plug 6 as y? Or as x? And solve that?
So why can't I plug this 6? Where did you want to plug it in? I'm so sorry.
Into the equation to figure out what y was.
Well, you could plug x equals 6 into the equation and figure out the corresponding y value, but that's not going to give you an intercept. So let's play along. So if you wanted to let x equal 6, we're looking at 2 times 6 plus 3y equals 12. Oh, so 2 times 6 is 12. Subtract 12 from both sides. You would have 0. Divide both sides by 3. Yeah, you get a y value of 0. That's just a way of checking it. So it's kind of like a cyclical thing. Does that make sense? You actually just took a minute to verify the idea that 6, 0 is in fact our x-intercept. So why we had to pick a different number is because we needed a different point. It takes 2 points to make a line. If I would have just kept with the 6 and the 0, I'm only ever identifying that blue point there, right? but I need another point to make a line, so I had to let x equal 0 this time around. So now I have 2 points, I can make my line. Gosh, am I answering your question? I hope I am. Yeah? Okay. Whew. Any other questions about that? Okay. Last thing I wanted to talk to you about today was, what about those horizontal and vertical lines? And, alright, so horizontal lines, our text recommends to graph them. They're, if we have y equals a number, it's going to be a horizontal line through the point 0, comma, number. Vertical lines are going to be a graph x equals a number, and it'll pass through c, comma, 0. Alright, so trying this out. I think about my hoi vux. Hoi, that's y, because OY ends in y, right? So that means hoi, that's a horizontal line. And it's going to pass through the point y equals -1. So first I go to where on my y-axis, y is -1, and I put a dot. And hoi begins with h, so I have to draw a horizontal line through it. So that is the equation y equals -1 plotted out for us. You might recall that's a constant graph. It has a 0 slope. Constant graph, whoa. And the slope of this line is 0. So it's that hoi vux played out again. Now, if I go to graph x equals 2, I'm going to go to where x is 2. That's right there. And this is that vux. So vertical vux. I'm going to draw a vertical line. Its slope is undefined. That's that undefined slope in vux. Yeah, and that's just it. It's vertical. If you wanted to say vertical, you could. Wow. I don't even know why that's happening. There we go. So, just like we had Dix-Roy yesterday, I got hoi vux for this. These lessons weren't supposed to be back-to-back. You're like, okay, enough with the acronyms, right? The mnemonic devices. But this one is helpful too. So the idea behind these sort of mnemonic devices that I give you is just so that you can actually just memorize the definition. It's just ways of memorizing a definition. So Dix-Roy helps you write the definition for domain and range, because domain is defined as a set of inputs and x values. Range is defined as a set of outputs and y values. Hoi vux helps you define horizontal and vertical lines. Horizontal lines are defined as lines that have a slope of 0, where their equation is of the form y equals a number. Y equals a constant. Vux, vertical lines are defined as undefined slope, or lines with an undefined slope. They fail the vertical line test, right? Because they're vertical lines. So vertical lines are defined as lines that have undefined slope, and they're of a form x equals a number. So hoi vux will help you remember which line is which. Let's try it out. Hopefully that little mnemonic device helps you out a little bit. I typed it real big there for you at the bottom of your page. And that was a super quick review of y equals mx plus b and ax plus by equals c. Your homework tonight. You do have 2-3 practice C